Welcome everybody, how are you? Now we will solve our questions about limited. Look at this example, limited when x approximated to 1, x over x subtract 1 over ln of x. First we must put 1. From any x we can cancel it and write 1. The result will be 1 over 1 subtract 1 over ln of x. It will be 1. The result will be undefined because 1 over 0 undefined, and here 1 over 0 undefined. So we must using the rule about this example. We must using the product of extremes equals the product of equal means, and we can find least common multiplication about two denominator here. So we can write limited x equal 1, and we can write here x subtract 1 multiply by ln of x, and ln of x multiply by x. The result will be x multiply by ln of x. Subtract x minus 1 multiplied by 1, result will be x subtract by 1. And we can find the derivative about numerator and denominator, because if you put 1 from numerator here, the result will be 0, and here 1 subtract by negative 1. We can complete it here, limited. We can simplify it, okay? Result will be here x minus 1 multiplied by ln of x, and here x multiply ln of x subtract x plus 1, and then we can write 1 here, 1 multiply by 0, ln 1 equals 0. The result will be 1 multiply by 0 subtract 1 plus 1, and here 1 minus 1 equals 0, and ln of x equals 0. The result will be undefined, any number divided by 0 undefined. So we can using derivative about numerator and denominator about x. So then, limited when x approximated to 1, we can find derivative about here, about this term, x multiplied of x. We can write the first multiply by derivative about second equal 1 over x, plus second ln of x derivative about x equal 1, subtracting the derivative about x equal 1, over we have two term, and we can find derivative about multiplication about two terms. The first here multiply by derivative about ln of x equal 1 over x, plus what we can write the first multiply second, and the second multiply the first, the derivative about the first, ln of x multiply by derivative about x minus 1 equal 1. So you can simplify it here, x divided by x equal 1. So limited when x approximated to 1, x over x equal 1 plus ln of x subtract by 1, and here x divided by x equal 1, now subtract 1 over x plus ln of x, and here we can put 1 in this example to find the result. 1 minus 1 equals 0, and ln of equal here I can write it here again, 1 plus 0 subtract by 1 over 1 subtract 1, y over 1 equal 1 plus ln of x 0. So the result will be 0 over 0, because in numerator we have 0 and denominator we have 0. So we must find the derivative again about numerator, okay, and denominator. So limited when x equal 1, the result will be 1, and will be subtract 1 equals 0. And ln of x derivative about ln of x equal 1 over x, and here 1 subtract 1 over x ln of x. We can find derivative about 1 equals 0, and derivative about x 1 over x. The result will be x power 2, x multiplied by derivative about 1 equals 0, subtract numerator divided the denominator here. So the result will be negative 1 over x2, because 0 multiply x equals 0, plus derivative about ln of x equal 1 over x. So the result will be here we have 1 over x when x approximated to 1. 1 over x equal negative 1 over x power 2 plus 1 over x, and then we can put 1 here from numerator and denominator. So the result will be here 1 over 1 equal 1, negative 1 over 1 negative 1, plus 1 here 1 over 1 equal 1, and we have negative outside here. Look at here, we have negative multiplied by negative equal positive here, okay, sign was negative. So the result will be 1 over 2, the result about this example. Look at another example. Find limited when x approximated to 0, cosec x subtract cotan x. We can write limited when x approximated to 0. We know cosec is inverse about sine of x, and the cotan equal cosine of x over sine over x. Okay, we can find derivative about numerator and denominator. So derivative we can write here sine, we can simplify it first, limit x equal approximated to 0. We can write sine of x and 1 subtract cosine of x, and then we can find derivative about here, about numerator and denominator about x. Limited when x approximated to 0, about numerator we can write 1 approximated 1 equals 0, negative cosine theta approximated cosine equals sine, negative sine multiply negative equal positive. The result will be sine theta, and derivative about sine equal cosine. This angle was x. Okay, sine x over cosine x equal 10x. We can write limited when x approximated to 0, 10 of x, because sine over cosine equal 10, and then we can write 0 here, 10 of 0. We can find the result about what, 10 0 about circle, unit circle here. We have 0, it's order 1 and 0. We know 10 over sine over cosine, sine 0 equal 0 and cosine 0 equal 1. So 10 equals sine theta over cosine theta. 0 over 1 equals 0. So tan 0 equals 0. It's okay. In this example, you must know properties. I will solve it again. Okay. Look at here. Limited when x approximated to 0, cosec x subtract cotan x. We must write cosec equal 1 over sine x is reverse about sine. Subtract cotan equal cosine over sine. And then we know we have least common multiplication about 2 term equal sine of x. Write it in the numerator here, and we can write 1 subtract cosine x. And then if you put 1 here, the result will be 1 subtract cosine 0 equal what? Equal 1, and sine 0 equals 0. The result will be 0 and over 0. It's undefined. So we must find derivative about numerator and denominator. Derivative about 1 equals 0, and derivative about negative cosine theta equals sine theta, or negative cosine x equals sine x, because derivative about cosine will be negative sine, negative multiply negative equal positive. And then sine of x over cosine of x equal tan of x. When x approximated to 0, then tan 0 equal 0, because tan equals sine over sine, and sine theta equal 0, and cosine 0 equal 0, so the result will be 0 over 1 equals 0.